Hello everyone. In today's video, I would like to talk to you about these resources to learn deep learning and machine learning online. These are resources that I have used myself, so I can attest for their quality, and I guess they will work for you too if you want it. First and foremost, uh, Python these days is the main language when we think about data science, machine learning, and deep learning. So if you want to start somewhere, start learning Python. This Python guide for beginners that I have here is a crash course that teaches you everything you know to get started. It You can also download the PDF version if you would like a book to follow through, and if you prefer this instead of this online version. You have introduction to Python, syntax, comments, variables, data types, typecasting, operators, data structures like lists and dictionaries, loops, while loops, for loops, functions, object-oriented programming. With this, you can go very far with your experiments in machine learning. So this is a good place to start. The Python guide for beginners here. Of course, I will leave all the links for these resources in the comments below, so you can easily follow through. Second, when we talk about machine learning, there is some math behind it. And of course, as a coder, as a software engineer, you don't want to spend like a year or I don't know, like 6 months only studying raw math. So what I have here, it's two playlists to go through covering linear algebra and calculus. These are the basics of math you're gonna need to understand the, the algorithms and why things work the way they work in machine learning. These two playlists are great. They have these visuals of how a vector behaves, or how a derivative works in a very visual way, so you can grasp that feeling of why this is the way it is, instead of just decorating some formulas for no exact reason. So these two are must watch, and they are very quick watches. So this one for linear algebra, it's just 15 videos, and they are on average like 10 minutes each. The calculus one, it's 12 videos, and they are like 15, 17, 20 minutes tops. So it's really quick to watch, much faster than taking a whole class on this, trust me. So this is a good place to start. If you feel like you need something more later, you will have this basis to, okay, I know what to look for, where to look for, and I think that's what matters the most here at the start. After this basic math, I would say you have to go to statistics. Again, you won't come out a statistician if you read this book, the same way you won't come out a mathematician out of these playlists. But this book, as the title says, 50 essential concepts. So if you know nothing or very little about statistics, this book will give you a broad overview of the main tools, how to use them, where they are applied, and it is a very fast read. It's really quick to grasp some concepts in statistics and some tools. And again, if you need something more, if you need to go deeper, you will know where to look and what to look for when you need it. So now that we covered the basics in terms of math and programming, Python, linear algebra, calculus, and statistics, here we will have our machine learning course from Mr. Andrew NG. He is the founder of Coursera. I'm not sure, but I think this course was the first course on Coursera. It is from 2011, and you may think, okay, why would I take a course from 2011 if I can take a up-to-date course from like last year about the subject? And my argument for this is I have yet to see someone to teach these concepts as clearly as Mr. Andrew does. Professor Andrew makes it very clear to understand, since from this very beginning, what machine learning is, when and where you apply it, the very basics from linear regression with one single variable. He also makes this linear algebra review, which is a great complement to the playlists I showed you before. Then he goes deeper on linear regression. They have this Octave MATLAB tutorial. You will read a lot of reviews on this course of people complaining that it still uses Octave, even though every single application of machine learning these days is made with Python or R, which is another language. But let me tell you this. The way the concepts are explained here are so well, it is so well done that this doesn't matter. You can easily translate everything you learn and apply it with Octave to any programming language if you want. Any. You can translate all the exercises that are done with Octave to Python if you grasp the concepts very well. And this course does that. Then after that, he goes through logistic regression, regularization. You actually implement your own natural neural network on this course with no extra layer of representation, with no extra layer of abstraction, so you know how it works from behind the scenes instead of using a library. So it is a good foundation. He gives some advice for applying machine learning, the kind of project you can use it on. He goes through support vector machines, unsupervised learning, and recommender systems, which are those kind of systems where you go on like Amazon.com, and they recommend you these books like that are related to the one to this one. That's a recommender system. He says, hey, if you are looking at this book, you might also like this and this and this. It's the same thing on Netflix, where you are looking for a movie and Netflix suggests like dozens of movies that are kind of similar to the one you are looking for. And at the end of the course, you do this photo OCR project, and this is a really good course. I can't recommend it enough for you to start in machine learning compared to any other material. But there is one thing this course misses, and it is random forest. Random forest is a major algorithm to classify data in machine learning. And this course by Jeremy Howard from FastAI covers this topic amazingly. His approach is top down, so first he shows you how the tool works, and then he shows you why it works. So you apply the random forest to the data set, you see how it works, why it works that way, and then he goes back all the way from the beginning and show you the behind the scenes of the logic behind it, the math behind it. It's a nice approach. It's different from the usual approach we see in a college, for example, in a university, which is the approach Mr. Andrew uses here in his course. So this is like a totally different approach. I really recommend you to see how different this is and how well he covers this topic of random forest. This is also free. The videos are hosted on YouTube. So Introduction to Random Forests, it's for it's just 12 videos of about maybe 2 hours, an hour and a half each. Okay. This covers what we call classical machine learning, and after that we go to deep learning, and my recommendation for that is Deep Learning Specialization by Professor Andrew and his team on Coursera. This course is from 2017, I guess, and I will make the same argument I did for the machine learning course. In this course, they cover TensorFlow 1.0, and we are currently on TensorFlow 2.0. So why take this course on this outdated version of TensorFlow, which is a library from Google to work with deep learning, in case you don't know? Because again, this series of 5 courses will teach you all of the concepts you are going to need to understand how these things work, and that's what matters. You can really, really easily go and learn TensorFlow 2.0 if you know these concepts very well, applied with TensorFlow 1.0. And TensorFlow 2.0 is actually easier because now they have Keras integrated with, which is a library that makes creating deep learning neural networks much easier than it was before. So I don't think that it is a problem. So which is very nice from this course is that it takes you exactly from the point you finish the machine learning course here, and it takes you to the next level. It's like a direct continuation of the first classical machine learning course. So he gives you this intro, then it gives you the second course on how to improve your deep neural networks, how to structure your machine learning projects, and then you learn about convolutional neural networks and sequence models. Convolutional neural networks are very well known for their applications on image recognition, while sequence models are very well known for their applications on natural language processing. Of course, you can apply sequence models to images and convolutional neural networks to other kind of data that's not images, but that's their main applications. And that's it. This is a very good course, and just to prove that I actually took those courses, here is my Coursera dashboard. Here you can see my name and here it is, completed the deep learning specialization and the machine learning course. So I'm telling you from my experience how good these courses are. Okay, so you know the basics, you know the concepts, you went through a lot, but okay, and now I want something more up to date. I want to get more, I want to go deeper. I highly recommend you this book by Mr. Aurielin. I read the first edition of this book, and then now we have the second version, which is even bigger and better than the first one. He goes from the very basics with NumPy and pandas up until NLP, image recognition, and unsupervised learning. This book is huge. It's more than 800 pages long, and he covers Scikit-Learn, which is a well-known library for classical machine learning algorithms. So all of the algorithms you learned in the first course by Mr. Andrew, they are implemented on this library. It's a must-know library for machine learning. Then he covers Keras and TensorFlow 2.0. The book has this more practical approach. He gives you a very good sense of how this work, and then shows you how to implement it. So it's a very hands-on book, as the title says. This is no clickbait. It actually delivers what it promises. I haven't finished the second book because it's too long at this point, but I've been through most of it, especially the parts that are very similar to the first edition, and it's great. I can't recommend it enough. It's really a really good book to go through. Outside of these books, I recommend you, after all of this, to go and look for PyTorch. While TensorFlow is a deep learning library by Google, PyTorch is a deep learning library from Facebook. It has a different approach to how you can implement neural networks on it, and they have very good docs, and I really recommend you to go through and look for it later. Again, if you have a good foundation with these specializations and these courses, you can pick it up, PyTorch, real quick, just to implement these concepts in a different tool. So that's it. Thanks for watching. Like, subscribe if you did, and leave a comment for me. Do you think there is a source, a resource, a course or book that I forgot in this, that you think that I should include? Again, these are all resources that I know, that I watched, that I read, that the courses that I took. So if there is something more that you think that I should look for, let me know. That's it. Thank you very much for watching. Bye.